Let's have a look at the type of tasks that different AI models can perform. These tasks can generally be classified based on the type of input data they accept and the type of output data they generate. Here are some examples. Text to text. This is typically used in machine translation, text summarization, and chatbots like Bard and ChatGPT. For example, if you ask GPT-4 what is a cat, it would tell you a cat is a small carnivorous mammal that is often kept as a pet. The term generally refers to, and then it keeps generating more information related to cats. Another model is text to image. This is used to generate images from text descriptions. An example of this would be Canva's text to image application, which creates images from text inputs. In this example, we can use the prompt a gray and white cat sitting on a windowsill watching pigeons outside, and it will generate this image for us. Text to video. AI can also be used to generate videos from text descriptions, although this is a more complex and less explored task than text to image generation. For example, using tools like InVideo, we can create a video with just a text prompt. The AI model uses our prompt to write a script for the video and then picks images and video clips that are relevant to the content of the script. It can even apply filters and transitions to the video. Some of these tools can also pick a music that is relevant to the content of the video. For example, the AI model can associate pets with playfulness and then pick a playful music to add to the video. Text to 3D. These models generate three-dimensional objects that correspond to a user's text description. For example, if you ask Shape E, a conditional generative model for 3D assets, to make an airplane that looks like a banana, it creates the 3D object you can see here. We also have text to code. These models are able to use natural language description and then create a code based on that. It is useful for tasks like automated code generation, error detection, and code translation. For example, ChatGPT, Bard, and GitHub Copilot share the capability to generate code. Models such as ChatGPT, due to their training on a wide range of internet text, including code, have the ability to generate code when provided with a suitable prompt. Bard, too, works along the same lines, but its training is specifically focused on programming related text. We also have GitHub Copilot that uses OpenAI's Codex model, which is trained on publicly available code, enabling it to suggest code completion and generate code from comments or function signatures. Text to task. Text to task models are trained to perform a defined task or action based on text input. This task can be a wide range of actions such as answering a question, performing a search, making a prediction, or taking some sort of action. For example, a text to task model could be trained to navigate a web UI or make changes to a doc through the GUI. We also have image to text. This is used in tasks like image captioning, where the AI describes an image in words. For example, Blip, which is an AI model capable of both captioning and generating images, can take an image as input and provide a description of that image in text as output. We also have image to image. These models perform tasks like image translation, for example, converting day images to night, colorizing black and white images, or enhancing image resolution. For example, Night Cafe is an AI image generator that can take an image as input to initialize the image creation process. It then produces a stylized image as output based on user's prompt and other settings that can be adjusted. Depending on the chosen algorithm, artistic or coherent, the start image serves different purposes. For the artistic algorithm, the shapes and structures in the image are more significant. But in the coherent algorithm, more attention is paid to resolution, colors, and textures. As another example, let's look at Canva's Magic Edit feature. Using this feature, we can select a specific part of the image and replace it with a different image. For example, here, I select the basket and then tell the model that I want to replace it with a mountain range, hoping that the result will make it look like the cat is sitting on a rock. And we can see that the model creates some suggestions for me. If I'm not happy with the result, I can ask the model to regenerate the results until I find something I like. And here is the final result. I can even go further and select the ceiling in the background and ask the model to replace it with a sky with clouds. And this is how the result looks like. Video to text. This involves generating a text description or a transcription from a video. For example, Aris AI can create transcripts or captions from a video input, even translating them from one language to another. While what we see in this example is captioning only the speech element of the video, some of the more advanced captioning tools are able to caption non speech elements as well. Non speech elements can include sound effects, for example, a bee buzzing, keys jangling, or doorbell ringing, music, either in the background or as part of a scene, audience reactions, for example, laughing, groaning, or booing, manner of speaking, for example, whispering, shouting, emphasizing a word, or talking with an accent, and speaker identification for an off screen narrator or speaker or for multiple speakers. Similarly, we have audio to text. This is typically used in speech recognition systems to transcribe spoken language into written text. Whisper by OpenAI is an example of an audio to text model. AI can also turn text into synthesized speech. Text to speech systems convert text into a spoken language. Many AI tools, such as Play.ht, can take a text input and generate human like speech with synthesized voices that can resemble different genders, ages, accents, or even different tones, such as happy, sad, angry, etc. Image to video. This task involves generating a sequence of images or a video from a single or a set of images. For example, cinematic photos, a feature in Google Photos, utilize machine learning to estimate an image's depth and construct a 3D representation of the scene, regardless of whether the original image contains depth information from the camera. Following this estimation, the system animates a virtual camera to create a smooth panning effect similar to a cinematic sequence. This intricate process uses artificial intelligence to transform a static image into a dynamic three-dimensional scene, giving it a video-like quality. What we discussed so far are just a few examples, and the list is continually growing as the field of AI progresses and as researchers invent new applications for these technologies. Furthermore, in many real world applications, these tasks are combined. For example, an AI system may need to convert speech to text using a speech to text model, and then process the text using a text to text model. And after that, generate an appropriate spoken language response, which uses a text to audio model. But wait, there's more. There are many other fields that Gen AI can have groundbreaking applications in. For example, just consider the world of music. Music related tasks are an active area of research and development in AI. Here are some common tasks. We have text to music. These models can generate music based on text inputs. For example, they can create a melody or a composition described by a phrase or a piece of text. Music to text. On the other hand, AI can also convert music to text, such as creating sheet music for a song or generating descriptive or emotional text based on a piece of music. We have audio to audio, which can convert one type of sound or music into another, like changing the genre of a song, turning a humming into a composed piece, or even removing vocals from tracks. There's also music recommendation. AI is heavily used in recommending music based on users' listening habits, preferences, and even mood. We also have music generation. MuseNet by OpenAI is one example of music generation. Models like OpenAI's MuseNet can generate 4-minute musical compositions with 10 different instruments and can combine styles from country to Mozart to the Beatles. There's also music enhancement. For example, Audio Studio can be used to enhance or alter existing music. It can do it by things like upscaling audio quality, changing the tempo, or adding effects. And there is also music source separation. We can also use AI models to separate individual instruments, vocals, or other components from a mixed or mastered track. Meta's Dmux is an example of a music source separation tool. So, in conclusion, the realm of generative AI is diverse, fascinating, and full of potential. The range of tasks it can perform, from text to image, audio to text, and even intricate tasks like music enhancement and generation, is truly remarkable. It's a field that's continuously evolving, pushing the boundaries of what we thought was possible. As we continue to explore and innovate, the list of applications is only going to expand. Generative AI holds the key to many breakthroughs and advancements that could revolutionize numbers of sectors and the way we interact with technology. As we continue to explore this exciting era of AI, who knows what astonishing possibilities we might uncover? The key is to stay curious, keep exploring, and start imagining a future in which we can interact with AI systems in a trustworthy, responsible, and ethical manner.